Good afternoon, my name is Genesis Medrano, and my partner is Illeana Ortiz, and today we're going to be talking about star formation in our astronomy class. So what is a star? Many will say it's a ball of light or a burning rock or maybe intelligent life outside of our atmosphere. But what actually creates a star, that's what we're going to be talking about today. Stage 1, out of the 7 stages that it takes to create a star, is the interstellar cloud. The interstellar cloud is also known as the molecular cloud. It is a very dense cloud that contains gas and dust. When the cloud contracts, gravitational instability causes it to break into smaller pieces, which is also later used to create the star. Astronomer Amelia Stewart took the temperature of interstellar cloud SP244 dark global and discovered that the mass has enough pressure to support itself against gravity. Stage 2 is a collapsing cloud. Basically, the purpose is to shrink the pieces of the interstellar cloud to the smallest possible, ball, which would later be known as a star. The fragment contains between 1 to 2 solar masses of material, and the temperature remains the same throughout the whole process. Stage 3 is that fragmentation ceases. It basically takes thousands of years to actually get from one end to the other of the fragmentation. Fragmentation becomes the size of our solar system. So it begins as a big cloud and it ends as the size of our solar system. And the core inside increases in temperature, which helps with the whole ceasing of the fragmentation. Stage 4 is a protostar. The protostar starts to evolve from the core of the fragmentation. So it begins from the middle of the core, and then it shrinks. Density begins to grow, and the temperature rises, which helps with the whole evolution of the star. Size is much larger, making the protostar much luminous from the sun. So it's brighter than the sun at this point. Stage 5 is a protostellar evolution. The protostar shrinks 10 times the size of the sun. So it's still bigger than the sun, but it's smaller than it used to be. The surface temperature and luminosity decrease. So you will see this actually helps slow down the contraction between the heat and the evolution. At the Atacama Larger Millimeter Array Observatory, astronomers were allowed to capture the process of the protostellar evolution through technology that we have nowadays. So we have actual evidence of that process being seen nowadays. Stage 6 is a newborn star. So it's basically after the whole temperature is going down and the ceasing of the fragmentation, it shrinks, has increased the central temperature enough to control or combust the nuclear burning. Protons begin to fuse into the helium nuclei of the core, so everything goes to the middle of the whole fragmentation, and that's how you get a newborn star. Stage 7 is the main sequence at last. So basically, here is where you actually get the star created from the whole process. The central density and the central temperature and surface of the temperature increase once again. And then the pressure and gravity finally balance each other out, so you have a star born from the protostars and so on. And the last outcome is the main sequence of the star. So at last you have that one star there you started from the beginning. This is our works cited. We were able to find all these evidence that show little stages of the whole process of the formation of a star. I'm glad you enjoyed our presentation. Thank you so much.